Alright, we're looking at number 21 and we're looking at this particular graph. So this particular graph, if you recall, is going to look like x minus 3 and then minus 1. So this one, remember, it's the opposite of what it has there, and then a negative 1. There's another way of telling you to move something. So if this is the parent graph, f of x was equal to x, and I state this, what it means is where you normally saw an x, you're going to put in an x minus 3, and then you're just going to subtract a 1 to the whole thing there. So you see that that gives me what it is that I'm looking for? So when you look at this, what this is telling you is actually to move it to the right 3 and move it down 1. So it seems like it should be saying move it to the left 3, but it's actually saying, hey, could you plug that into the equation? And when you put it into the equation, it always ends up being the opposite. So looking here, if we're looking at graph 17, you can find that real quick. This is the graph that we have. So let's just look at what it is. My vertex is at negative 1, 3. So my equation would be x plus 1 cubed. Remember, it's a cubic. It's going up on this side and down on this side, and then plus 3. So if I wanted to give instructions for that, I would just say, hey, where you normally have, this is our normal, whoops, sorry, this is our normal one, where you normally have just an x, I want you to plug in an x plus 1. And where you normally didn't have anything else, I wanted you to go ahead and add a 3 to it. So what is this instructing? This is instructing, just move it up 3. This is instructing to change your equation so that it is moving to the left 1. So let's go ahead and look at graph 20. Good stuff here. We have our graph 20. So for our graph 20, what's happening? We have a negative 1, 3 as our vertex, and which means that, and this is our square root function. So remember, if it's negative 1, it's going to be a plus 1, and then it's a plus 3 because it's moved up 3. So what if we wanted to do this? So in order to do that one, we're supposed to be changing and moving our graph to the right 4. So that's what this says, is change it and move it to the right 4. There's no words in there, but that is what it's saying. So if this is my original vertex, and if I move that to the right 4, I'm going to be at 3, 3 for my new vertex. So graphically, I will be at 1, 2, 3, 1, 2, 3. And this is my square root function. So I used to be here, and now I moved it to the right 1, 2, 3, 4, and so now it's this location. That's what happened graphically. Algebraically, what you can do is you can say, well, this is my x, so now I'm going to plug this in where I used to see an x. So if you do that, you get x minus 4 inside where it used to just be an x. And then when you do this math, you get x minus 3, which in turn gives you the vertex of 3, 3. So I'll say that again. This is the instruction to take whatever this is and to move it to the left, to the right 4. So I can physically take it, move it to the right 4 and get my equation. But algebraically, that means that if I take what used to be an x, so I take this guy here, and I change it, or I sub in an x minus 4 into this equation here. So I have x minus 4 is what used to be my x. I'll get my x minus 3, and then I still have my 3 outside there. Either way, you can see I still end up getting this equation with this particular vertex or locator point.